Hello and welcome to 3.8 Newton's method. In this section we're going to be looking at a method for approximating the real zeros of a function. So what helps is if we have the graph of the function, and then we could use what we call an initial guess, first estimate, to plug into a formula. Okay, it's a formula that will be a little repetitive, but it eventually gets you to the approximate zero, and it's actually very accurate. So I'll walk you guys through how it works. So the method for approximating zero, we make an initial estimate that is close to our zero. Okay, and a graph is helpful. So looking at the graph of it, so if you have like a Desmos or a graphing calculator, you could plug it in, look at it, and then take the initial guess. Okay, and then to determine a new approximation, we go through some steps. Okay, and this is the general formula. We have our new estimate will be based on our first estimate minus the function when we evaluate it at our first estimate divided by the derivative when we evaluate it at our first estimate. Okay, and then we just keep repeating the new step, and so that gives us our new estimate, and then we would keep repeating it until we get to within our desired accuracy. Okay, so let's see how this works. Calculate 3 iterations of Newton's method to approximate a zero of f of x equals x squared minus 2. Okay, use x1 equals 1 as our initial guess. Okay, so looking at the graph of it, x1 equals 1 is right here. Okay, and so we're trying to get to about like right here. 1.5 would be overestimating it, but we're trying to get to like right there. Okay, now we could easily figure out what the zero is by solving this equation equal to 0. Okay, but that's not the point here, right? We're trying to see if this method would actually get us very close. In fact, to see what it would actually be, let's do that real quick. X squared minus 2, set it equal to 0. Add 2. So we get x squared equals 2. Take the square root, so we get x equals plus or minus the square root of 2. So the zero that we're looking for would be the positive square root 2 here. There will be another one on the other side of the x-axis at negative square root 2. But this one we're particularly interested right now is the positive square root 2, which if you take the square root of 2, it will be approximately 1.4 with a bunch of decimals after it. Okay, so let's take a look. So this is our first step, n is 1. x1 equals 1 is our initial guess. So this first step, we have this broken down. First you're going to do f of x, then you'll do the derivative when we plug in our xn. Then we have a fraction of f of x over f prime of x, and then xn minus that fraction. Okay, so it's a pretty standard process here. If we plug in 1 into our function, 1 squared is 1, 1 minus 2 is negative 1. our derivative. Let's write our derivative function here as well, since we're going to be using it. Derivative function would be 2x. Okay, so the derivative, when we plug in 1, 2 times 1 is 2. Our fraction, f over f prime, so take the two numbers, divide them, so that's negative 1/2. And then xn minus the fraction we just had, so it's like doing 1 minus negative 1/2, so that becomes, I'll go to decimal now, 1.5. Right, double negative means we're going to add it. Okay, so now that 1.5, that becomes our new xn. This is for step 2. Okay, so now plug in f of 1.5. So plug it into our function. That's 1.5 squared, which is 2.25 minus 2, which is 0.25. Okay, now we take 1.5, plug it into our derivative. 2 times 1.5 is 3. Okay, next we take 0.25 and divide it by 3 for this fraction. Okay, so that's about 0.08333 repeating. Okay, and then finally xn, so 1.5 minus 0.08333 repeating, and that gets us 1.41666 repeating. I'll make the last one here 7. Okay, so you actually see within 2 steps we're actually very close to our actual 0. Okay, and so now let's use 1.416667. This is step 3. Okay, now do f of xn, so plug in 1.416667 into our function. Square it minus 2. Okay, so that gives us 0.006945. Okay, let's take our 1.416667 number, plug it into our derivative. Okay, so just multiply by 2, so 2.8334. Okay, make a fraction of f of xn over f prime of xn. Okay, and that gives us 0.002451. And then finally take xn minus this number, so 1.416667 minus 0.002451, and we end up with 1.414216. Okay, so that's actually very, very good, because if we look at the square root of 2 again on the calculator to 6 decimal places, which is what we have here, square root of 2 gives us 1.414214. Okay, so only difference after 3 steps is this last digit. This is amazing. So we're accurate to within accurate to within 0.000002 of the actual 0. Okay, so it's a pretty interesting method for approximating a 0. Okay, let's take a look at this problem. Now this one, function is e to the x plus x, and we're trying to approximate the 0. Okay, so for our first guess, let's take a look at where our graph is going through. Looks like it's a little bit past the negative 0.5 mark. I would even say like negative 0.6. So for my first guess, let's say negative 0.6. Okay, so now if I plug this into my function, okay, plug it into x and x, so we would get negative 0.05119. Okay, let's get the derivative going. Okay, so derivative of e to the x is e to the x, and derivative of x is 1. Okay, so that's our derivative function. So let's plug in negative 0.6 into our derivative, use a calculator. So we end up with 1.54881. Okay, make a fraction out of our f of x and our f prime of x. Okay, so that gives us negative 0.03305. And then negative 0.6 minus this number, that gives us negative 0.56695. Okay, so now take that number, that becomes your new xn. Okay, so negative 0.56695. Okay, now take that, plug it into our original function. Okay, and we get 0.00030. Okay, plug it into our derivative, the negative 0.56695, and we get 1.56725. Okay, make a fraction out of f of x and f prime of x. So 0.00019. And now finally subtract xn minus this number, and we get negative 0.56714. Okay, so that becomes our new number. Negative 0.56714. Okay, plug that into our function. Okay, that gives us 0. Zero point zero zero zero. Take this number, plug it into our derivative. We get 1.56714. The fraction would be 0. And then our xn minus our fraction, which will just be negative 0.56714. Okay, so it looks like we zeroed in on our actual 0. Okay. So we see that two successive approximations, they differ by nothing, basically. We can estimate our 0 for the function to be negative 0.56714. Okay. And that's it. That's the technique. Very, very effective. Usually will get you to your desired accuracy within 2 or 3 steps, usually. Sometimes, of course, there are exceptions to the rule, but very, very interesting and accurate method for approximating zeros of a function. Okay, any questions, just let me know, email me. That's it for this lesson. Have a good day, have a good night. We'll see you soon.